let's move on to the analyzers in mass spectrometry. In your syllabus, all three branches, you have only two types of analyzer: quadrupole analyzer and time of flight mass analyzer. Let's start with quadrupole analyzer. Okay, so in quadrupole, the name itself is suggesting there are quadra means four, and pole means there are four electrodes. So it is a compact, very less expensive, more rugged than most other types of mass spectrophotometers. Its scanning rate is very high. Entire mass spectrum can be obtained in less than 100 milliseconds, so it is extremely fast. Let us see its construction. I want you people to focus on the diagram first. Okay, you can see there are four rods. They are placed opposite to each other. Two of the rods are attached to negative terminal of the battery. You can see negative terminal of the battery over here, and two of the rods which are oppositely placed are attached to positive terminal of the battery. There is arrangement such that the voltage between the rods will change alternatively. Okay, it will change alternatively, and the frequency with which it is changing, it is radio frequency. Okay, it is a radio frequency. Now, please tell me whether you can show that hand, that pointer, what I'm trying to point out. Can you see it?
No, sir.
Okay, you cannot see the pointer. Now, can you see that hand, small hand?
Yes, sir.
Yes, sir.
Okay, thank you. So, as I was telling, these are two positively charged rods. They are connected to positive terminal of this battery, and these two are negatively charged rods. They are connected to negative terminal of the battery. Now, this is attached to a radio frequency, you can say voltage generator. What happens is, when at one time, at the moment, you can see there are two positive and two negative rods. Those same rods, when this voltage is applied, this RF voltage is applied, it will overcome this battery, because it is also attached to a battery. You can see it will overcome this battery, and the originally positively charged rods will become negatively charged, and negatively charged rod become positively charged. And this changing of the potential, it will occur with the frequency of radio waves. Okay, so in megahertz. Okay, in 1 second it will change 60 to 70,000 times. Okay, there is a small aperture over here. From here ions they enter, and depending on their mass, and frequency with which the rods are changing their potential, they will travel between the gaps of these four rods. Okay, at certain frequency, suppose frequency is comparatively lower. Now you need to try to imagine the frequency is comparatively lower. So in the ion mix that is in between the rods, you have heavy ions and you have very light ions. Okay, and the frequency of changing of the voltage is very low. At this particular stage, there will be a certain path followed by the light ions and the heavy ions.
ये उसको किसने दिया? ये उसको किसने दिया?
दिया नहीं है, ये बुलाई मेरे पास।
मैडम ये इन्फॉर्म का है। उनको बताइए ये इन्फॉर्म का है, ये बी फॉर्म का है, और ये मैंने नहीं बनाया, ये टीचर्स ने बनाया है।
Okay, so the ion. So okay, I was telling that the frequency is low. Now imagine the ion which is positively charged and it is very lightweight. Okay, so the moment it is near to a negative rod, if the ion is light, it will immediately hit it. Okay, because its weight is light, it can travel faster. But the ion which is comparatively heavy, when it travels near this negatively charged rod, the negative rod becomes positive. Okay, so it will get repelled from there. Okay, it will get repelled from there, and at low frequency the heavy molecules will travel all the way to the detector. Now try to imagine the frequency of change in the rod potential is very high. Okay, now because it is very high, when there are small ions going, okay, it will reach to this negative. Immediately that negative negatively charged rod becomes positive. So it will change its path and will go to the immediate next negative rod. That by the time it is reaching going near to that negatively charged rod, it becomes also positive. So it will repel. So it will spiral its way till this opening and it will escape the quadrupole. Now imagine at a high frequency, a heavy ion is present. That heavy ion, when it is attracted towards this negatively charged rod, although it has become positive in the next instance, the heaviness gives that ion momentum. So even if it is positively charged, it will be able to hardly change the direction. And instead of going to the next rod, it may escape the path. Okay, it will escape between the rods. So depending on the frequency of the radio frequency, it determines whether light ion or heavy ion will reach to the detector. Okay, let's see what is written over here. It consists of 4 parallel cylindrical rods that serve as electrodes. Opposite rods are connected electrically, one pair being attached to the positive side of a variable DC source and the other pair to the negative terminal. In addition, variable radio frequency AC voltage, which are 180 degrees out of phase, are applied to each pair of rods. Quadrupole mass spectrometer with ranges that extend up to 3000 to 4000 mass by charge are available from several instrument manufacturers. These instruments easily resolve ions that differ in mass by 1 unit, so they are very sensitive. Now, generally quadrupole instruments are equipped with a circular aperture rather than slit to introduce the sample in the dispersion region. The aperture provides a greater sample throughput rather than that can be tolerated in magnetic sector instrument, in which resolution is inversely proportional to slit width. So here they are comparing this quadrupole with the conventional mass analyzer. Working of it, ions are accelerated into the space between the rods, that is this space between the rods, by potential difference of 5 to 10 volts, which will be applied over here. Meanwhile, the AC and DC voltages on the rods are increased simultaneously while maintaining the ratio constant. So the potential difference between them will be maintained, but the frequency by which they changed positive to negative, it is changed. At any given moment, all the ions except those having certain MZ value will strike the rods and are converted into neutral molecule, and remaining will pass through the gap. Thus, only ions having limited range of MZ values reach to the transducer or the detector. So this is what I was talking. You can see the animation over here. Actually, these images were also animation. I don't know why they are not working. See, the right weight molecule passed, this one got neutralized and this one got escaped. Observe these two animations. बोला ना urgent है. Okay, so this is actually the scanning. In previous two animation, there was the constant rate applied. Now here the rate varies throughout the analysis, and you get all the mass got detected. This is explanation. You may not go a little deep into this. Where I have explained, that is sufficient. Okay, next is time of flight.